Colby, 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 math.com.
On this computation help video, we're going to go over all the rules for integer operations and also use some models to try to understand why those rules work. The rule for integer addition is going to make more sense after we work with it a bit, but the rule is when you're adding two integers, the integer with the greater absolute value determines the sign of the sum, and I'll explain what that means as we go here. Here's the first problem I'd like to look at, and we're going to model this equation. -3 plus -2 is equivalent to -5. And you can see that on a number line. If I make a number line and I show the origin, we can model -3 this way. We know it's 3 to the left of the origin. So that's -3. And to -3 we're adding a -2. So if we're adding -2, which direction are we going? We're going 2 to the left. So here's the -2 that we're adding, and where do we end up? We end up at -5. And so that's a way to model integer addition. If you're adding two negatives, your answer is just going to be more negative. I mean, you just keep going to the left on the number line. If we had a problem like this, -3 plus +2, our model would start out the same way. We start at the origin and represent -3, 3 to the left of the origin. But then if we're adding +2, we're not going to go left. Now we're going to go right with our arrow. So the arrow goes 2 to the right, and where do we end up? We end up at -1. And so here's what it means about the add-in with the greatest absolute value. Absolute value means how far is the number from 0. So the absolute value of -3, you can see that -3 is 1, 2, 3 spaces away from 0. So the absolute value of -3 is 3. The absolute value of 2, +2 is over here. 2 is 2 spaces from 0. So the absolute value of 2 is 2. And since 3 is greater than 2, the -3 determines the sign of the sum, and the sign of the sum is -1. You can see that from the model, or you can see that by considering the absolute values. The reason that works is if I'm starting with -3, I would have to add at least 3 just to get back to 0. I would have to add more than 3 to get back into positive territory. Another thing to think about is -3, you could think of it as 3 negatives, and if you add 2 positives, we call these 0 pairs. So every pair of a negative and a positive equals 0, and they go away, and you're left with 1 negative or -1. Here's one more, -5 plus 8. Again, we would start at the origin and represent -5 would be 5 to the left of the origin. And then to that -5, we're going to add +8. But before we do that, this time let's think about what will be the sign of our sum. The absolute value of -5 is 5, because it's 5 spaces away from 0. You can see that very clearly on the model. The absolute value of 8 is 8. 8 is 8 away from 0. And so since, in this case, the positive number, the positive integer has a greater absolute value, our sum will be positive. If we add 8, we're going 8 to the right. That's going to take us to the 0 and beyond, three spots beyond to +3. So -5 plus 8 is equal to +3. I put this one on here so we could talk about what is this modeling. If we start at the origin, our first add-end is 5, +5. And then from there we're going to the left, so we're adding a negative. But what are we adding? Negative what? We're moving 1, 2, 3, 4, 5 to the left just to get to the 0, and then 3 more. So we're going back this way, -8. So 5 plus -8 is equivalent to -3. Just realized something. Rather large oversight on my part. There's a whole lot of integer addition there, but no integer subtraction. All right, let's talk about integer subtraction for a second. Pretend this is not here. Somehow I left off part of this. We're not going to model it. We understand how integer addition works, and subtraction is addition. Subtraction is just adding the opposite. So if I have 8 minus 5, for example, we know that's 3. 8 minus 5 is 3, right? It's the same as, subtracting is the same as adding the opposite. So 8 minus 5 is the same as 8 plus the opposite of 5, which is what? Negative 5. And if I have 8 plus negative 5, I have 3. If I have 2 minus 7, subtracting is the same as adding the opposite. So I'm subtracting positive 7. That's the same as adding the opposite of positive 7, which is negative 7. And so in this case, we'll get negative 5. So you just, in order to do integer subtraction, you just need to understand the definition of subtraction, which is that subtraction is the same as adding the opposite. They're inverse operations. And so if you rewrite subtraction as addition, I mean, in many cases you won't need to. If you see 8 minus 5, you just know it's 3. And you've been doing that forever. If you have negative 3 minus 2, you may automatically know that that's negative 5. If you can sort of visualize, I'm at negative 3. If I'm subtracting 2, I'm going more negative. And some students can just see that, and some students need to change it to addition. Either way is fine. If I change this to addition, subtracting positive 2 is the same as adding the opposite of positive 2, which is negative 2. And negative 3 plus negative 2 is negative 5. Okay, so that's integer subtraction. Let's talk about integer multiplication and division. The expression 2 multiplied by 5, positive 2 multiplied by positive 5, can be modeled as two groups of 5. So there's a group of 5, and there's a group of 5. Two groups of 5 is equal to 10. So if this is positive 5, all the yellows are going to be positive. We're going to see reds later. The reds are negative. So if this is, these are all positive. I have 5 here. There's one group of 5, and here's my second group of 5. Altogether I have positive 10. So if we have positive multiplied by positive, we get a positive. 4 multiplied by 3 is 12, 3 multiplied by 7 is 21. So positive multiplied by positive is positive. If we have a positive multiplied by a negative, we can model it this way. I have 2 multiplied by negative 5. I have two groups of negative 5. Here's a group of negative 5. Again, the red are going to be negative. So there's a group of negative 5, and here's my second group of negative 5. So if I have two negative 5s, if I have two groups of negative 5, what do I have? I have negative 10. So 2 multiplied by negative 5 is negative 10. 6 multiplied by negative 4 is negative 24. 8 multiplied by negative 2 is negative 16. So positive multiplied by negative is a negative. A negative multiplied by positive, so we have negative 2 multiplied by 5. This can be thought of this way. It can be modeled as the opposite, because negative means opposite. The opposite of 3 is negative 3. Negative is opposite, and if you think of it as opposite, it helps you understand how a lot of these situations. So I'm going to think of this as two groups of 5. So here's a group of positive 5, and here's another group of positive 5. But if I take the opposite of that, the negative of that, I flip them over, and now I have two groups of negative 5, or negative 10. So the opposite of two groups of 5 would be the opposite of 10, or negative 10. We could also solve that by thinking about the commutative property. Negative 2 we know that, let's think about this for example. 3 multiplied by 7 is 21, and 7 multiplied by 3 is 21. You know that commutative property that you can, if you have multiplication or addition, you can change the order. And so if we change the order here, a negative 2 multiplied by 5 is the same as 5 multiplied by negative 2. And in the previous model we did, we said a positive multiplied by a negative is a negative. This would be 5 groups of negative 2. So that would also be negative 10. Also another way to show that it's negative 10. So negative 2 multiplied by 5 is negative 10. Negative 9 multiplied by 3 is negative 27. Negative 4 multiplied by 7 is negative 28. And in general, a negative multiplied by a positive is negative. The last case we need to think about is negative multiplied by a negative. So we're going to use the same idea we had before of thinking of this first negative as the opposite. So if you look at what's inside the brackets, we can model that as 2 groups of negative 5. So here's a group of negative 5, and here's my second group of negative 5. So what's in the parentheses is negative 10. But what's the opposite of negative 10? If I flip these over to their opposite, we get positive 10. So negative 2 multiplied by negative 5 is positive 10. A negative multiplied by a negative is a positive. The opposite of 2 groups of negative 5 would be the opposite of negative 10. It would be positive 10. Negative 3 multiplied by negative 6 is positive 18. Negative 11 multiplied by negative 7 is positive 77. So a negative multiplied by a negative is a positive. And let's look at division now. 24 divided by 2, you know that's 12. 36 divided by 9 is 4. So a positive divided by a positive is a positive. You've been doing that forever. I want to think about how we can use the definition of division to compare this to multiplication, because earlier on this video we said that the definition of subtraction was that subtracting is the same as adding the opposite. That's because addition and subtraction are inverse operations. Well, multiplication and division are also inverse operations. Dividing is the same as multiplying by the reciprocal. So 24 divided by 2 is the same as 24 multiplied by the reciprocal of 2, which is a half. And if we know that a positive multiplied by a positive is positive, then a positive divided by a positive should be positive. A positive divided by a negative is negative because the reciprocal of negative 4 is negative 1/4. Multiply those, we know a positive multiplied by a negative is negative. So that's negative 4. If you're dividing, you just divide. 16 divided by 4 is 4. But if it's positive divided by negative, it's negative. 15 divided by negative 3 is negative 5. Positive divided by negative, negative. It's the same as a positive multiplied by a negative is negative for the same reason. Division is just multiplying by the reciprocal. Negative divided by positive, also negative. Negative 33 divided by 3, negative 11. Negative 54 divided by 18, negative 3. Negative divided by positive, negative. Negative divided by negative, same as negative multiplied by negative, it's positive. So negative 25 divided by negative 5 is 5. Here's another way to prove that. Division means, okay, so if I have 12 divided by 3, that means how many 3's are in 12? There are 4 3's in 12. How many negative 5's are in negative 25? If this is negative 5, how many of those would be in negative 25? Wouldn't I need 5 rows of those? I'm not going to do them all, but wouldn't I need 5 negative 5's to make negative 25? I would need 5 groups, positive 5 groups of negative 5 to make negative 25. So negative divided by negative is positive. Negative 21 divided by negative 7, positive 3. negative divided by negative, positive. If we look at these in table form, positive multiplied by positive, positive, positive multiplied by negative, negative, negative multiplied by positive, negative, negative multiplied by negative, positive. And the same rules apply to division, because division is just multiplying by the reciprocal. So this is positive, positive divided by negative, negative, negative divided by positive, negative, and negative divided by negative, positive. So those are all the rules. You have lots of practice below the video. Thanks for taking the time to watch this and do the extra work to get better at these computation skills. I appreciate it, and I hope it helps.